So absolute value inverses are tricky, just like you have to add a plus minus to the square root. You have to add a plus minus to the absolute value. So it doesn't matter what absolute value I choose here. I can't remember which one I gave you. But let's say it's got a bunch of stuff inside of it. But just pretend that's the absolute value sign there. And I've got x plus 2, and then I even add a 3. You do the same technique. You treat the brackets like brackets in BEDMAS, and you list the things that are going on. X is having 2 added to it. And then you say x is having an absolute value done to it. And that just means plus and minus. We'll get to that in a second. And then 3 is multiplying. And finally, the last step, 4, and I'll change this up here. I'll make this a different number. 4 is being subtracted. So now you do the inverse starting with the last step. Add 4 both sides. Divide by 3 both sides. I'm going backwards in the step and doing the opposite math. And then for the absolute value, to get rid of the absolute value, you put whatever you have so far in brackets, and you add a plus and minus in front of it. And then you just whatever's in the brackets. And then finally, the last thing, 4, subtract 2, both sides. So here's what that looks like. Now let's first of all look at the vertex of this graph. It's at -2, -4, and it's facing up, which means this y value dictates the range. Y is bigger, equal to 4. That means when we find the inverse, the domain will match that range. X is bigger, equal to 4. So you have to add that as a restriction here. X is bigger, equal to 4. And we'll see if that works out. And then over up here, it's XER for the domain. So down here, it's YER. So the domains and the ranges flip. Okay, let's try this. And we're going to pull up a bed Desmos here. And I'm going to just add the values we have here. It doesn't matter which absolute value, x plus 2 minus 4. Okay. So we can see from this graph that the vertex is here. So we can expect a swap of those numbers for the new vertex. So expect -4, -2 to be the new vertex. It's also going to face to the right. So now let's take this thing here. By the way, if ever you want Desmos to draw the inverse cleanly, just switch the y for x and the x for y, and you'll see what the inverse should be. Okay, let's go back and just keep it normal. Now let's subtract 4 from both sides, or add 4 to both sides rather. Let's put this in the brackets on the left side. Let's divide by 3 on both sides. And now to get the absolute, let's put it in brackets here and here. We're going to make one version like you did on, this is a way of putting plus, minus, and Desmos, but I can't remember it quickly. So we'll make one version positive and this version down here negative. And then finally, that gets rid of the absolute value. And then finally, we've got to subtract 2 from both sides. And then the last step is you've got to switch your x and your y's. This has got to be the new x. This has to be the new y. This has to be the new x. Sorry, the new y, and this has to be the new x. Notice that without the domain restriction of x is bigger or equal to 4, we won't have the right drawing. There we go. Oh, sorry, what was it before? -4, x is bigger than -4. There we go. And we'll put the same restriction on this one. There. Without the domain restriction, the drawing doesn't work. It's because it's essentially 2 lines that you're restricting the domain on. And that's one way of doing inverse of a absolute function. Now, hang on, I'll cover a couple more here that are important. As soon as I find my thing here, pull it up and pause. Okay, so the inverse of a radical is a little easier. But notice that radicals are just one side of it. Make sure that when you do the inverse, you don't do a parabola. It's just got to be one side of it. Sometimes it's hard to figure out which side until you realize if it says, for instance, 2, 4 here, 2, 4, it's got to say 4, 2 here. So you'll be able to figure out which side. Let's take a simple radical. Let's call like y is equal to square root, and inside of that we'll do x minus 4. And then outside the square root, we'll just add 3. So we're going to subtract 3 from both sides. Then we're going to square both sides. And this is what would create the parabola by mistake. And then you add 4 to both sides. And then you switch your x and your y. Now the problem is that will look like a parabola. So you have to go back and look at the range restrictions here. The range restrictions here, because the whole thing has been shifted to the right, the domain and the range restrictions are x is bigger or equal to 4, and y is bigger or equal to 3. And that means the domain range restrictions for this one will switch. X will be bigger or equal to 3, and y will be bigger or equal to 4. Let's try out this theory. Plus 3, I got it right. X minus 3 plus 4. X minus 4 plus 3. There we go. Now, according to me, the inverse will be this. But the problem is that creates a parabola. So as we could see up here what the restrictions were, so I'll just put the restrictions here. Up there was x is bigger or equal to 4, so down, and y is bigger or equal to 3. So here it's x is bigger or equal to 3. And that will draw the correct half. My mistake, I had the wrong half. All inverses always look like they're reflected in this mirror. Y is equal to x. So that's what it should look like. It should look like the same thing happening on either side of that red line. You can also test any 2 points. For instance, you can go, okay, well, this point's at 5, 4, so I should find the point 4, 5, which is there. So you can always find the inverse points if you've done it correctly. But without this domain restriction, it's going to look like a parabola. Rational inverses are much harder, and I don't think your teacher wants you to do rational ones. Rational ones, let's say you have 3 times x, 3 times 1 over, or even sometimes you'll see it like this, 3 over x plus 1, like that. So the secret to this is you have to move the x plus 1 together. Since it's 3 divided by that, you just multiply both sides by x plus 1, like that. And before expanding it, it cancels here. Before expanding it, you just divide both sides by y. So far you get this. Now that that's gone, we get rid of the brackets, and we just subtract 1 from both sides. And then we swap our y and our x. Now, sometimes you'll see it written like that, but not often will you see it written like that. Often they'll put the 1 over the same denominator. So let's see if they'll do that. Yeah. Nah. Yes and no. This is acceptable, but if I wanted to put it over x, I'd multiply top and bottom by x. And then you get 3 minus x over x. Yeah, I think your teacher might prefer the first one. And even this one, you would reorganize it to minus x plus 3 over x. But I don't think your teacher wants you to do that. So again, this is good enough right here for an answer to the inverse. And to prove it, you pull up Desmos. You put your inverse. Y is equal to 3 over x minus 2. And then you put, and this is going to be a difficult inverse to see. And then it's this 3 over x plus 2. And you might not be able to see it even when you draw the mirror line. But yeah, it makes sense now. On either side of the purple line is the same image. And these are always tough to draw. Yeah, it wasn't plus 1, sorry. I added 2 to both sides. I don't know why I put plus 1 in there, plus 2. Whatever was in the equation. Oh, it's just, it was plus. No, it was, let's see. Yeah, it was minus 1. Sorry, minus 1. So long as the two equations match. So minus 1 here, plus 1 here. There we go. Those are the two equations. A little harder to do.